So in the last module, we learned about perfect competition, and in this module, we're going to look at the market structure of monopoly. In this module, we're going to focus on identifying the profit-maximizing price and quantity for a monopolist, which will be different than it was under perfect competition, and will determine whether a monopoly is earning an economic profit or a loss. Now, here's something to keep in mind when we look at monopoly, the difference between memorizing and learning. Okay, try memorizing this number. Now, how effective is it going to be to memorize it? The point I'm trying to make is that if you try to memorize all the graphs of economics, you're going to forget them. You have so many different graphs you have to know for the AP exam. Some of these graphs you'll be shown and you'll have to interpret information from them. Other graphs you'll actually have to draw. Label all of them properly, draw all the curves correctly, show all the information that you're asked to show correctly, shade different areas correctly. And if you try to memorize all of those, you're going to get them confused and memorize them. You have to learn them, and learning them means understanding them. It means that you know what those curves mean and why they are drawn the way they are drawn and how the different areas of profit and loss operate and things like that. If you truly understand them then and what is happening in each market, then you'll remember how to draw those curves properly and those graphs properly. But if you just memorize them, it's going to be very difficult for you. So as we look at monopoly, here's a reminder of the 4 different types of market structure that we look at. In the last module, we focused on perfect competition, but now we're going to look at the 3 different types of imperfect competition. And in the next few modules, we'll focus at the opposite end of the spectrum, which is pure monopoly. But remember, every product is sold in a market that can be considered in one of the above market structures. Now, you probably are familiar with Monopoly. You've probably played the game Monopoly, and you remember this character, the Millionaire Man from Monopoly. And remember, the goal in Monopoly is for one person to control all of the property. And that's what Monopoly is. So Monopoly falls at the opposite end of our different types of market structures. Under Monopoly, there is only one large firm in the market. It has no competition, unlike perfect competition, where there are hundreds or thousands of firms that were all competing with each other. This is because that one firm produces a unique product that no one else does, and there are no close substitutes to that product. Now, monopolies then are price makers. They can set a price above what the market price would be under perfect competition, and therefore, they have more market power than any other type of market structure. And so we call them price makers because of this power to be able to set their own price. And because of that, they will be making economic profits. That would normally attract other firms to enter the industry and take some of those profits away. The reason that they can't is because there are high barriers to entry that prevent firms from entering the industry and competing with the monopoly. There is no entry or easy exit like there was under perfect competition. And there may be some advertising with monopoly as well. Now, what do you already know about monopolies? See if you think each of these statements is true or false. Do all monopolies make a profit? Are all monopolies usually efficient? Are all monopolies bad for the economy? Are all monopolies illegal? Do all monopolies charge the highest price possible? Does the government never prevent monopolies from forming? Let's look at the first question. Can a monopoly be good for the economy? Well, in some cases, yes. Here's an example. Think of electric companies, power companies, like Xcel Energy in the Denver metro area that provides gas and electric power to our local customers. Now, instead of having just one company like Xcel, what if there were 3 competing electric companies? Well, the problem with that would be that they would all have higher costs of producing electricity than one company alone. Having only one electric company keeps prices low. Why? Because in the electric power industry and the gas industry, there are economies of scale. And as we've seen, when there are economies of scale, the average total cost of producing a good goes down and down and down the more units you produce. So if we actually had more companies competing with each other, they would each be producing at a higher average total cost. So it makes it impractical to have smaller firms. When this condition exists, when there are economies of scale over a long range, and it makes more sense to have one company producing at a lower average total cost than multiple companies producing at a higher cost, then we call that a natural monopoly. because it is natural for only one firm to produce rather than multiple firms because they can produce at the lowest possible cost. And that makes it good for the economy. Now we have to consider how we draw monopolies. Well, here's the good news. First of all, under perfect competition, remember we had to draw two side-by-side graphs. One showed the industry supply and demand curve, what we called the market demand and supply graph. And side by side, we showed the demand and supply curve for an individual firm in the market. But under monopoly, the industry and the market are one and the same. Because the monopoly is the only producer, it is also the market. And so the monopoly graph and the industry graph are one and the same. So you only have to know one graph. The cost curves are the same as they were under perfect competition. The profit maximizing quantity of output is still the same, where marginal revenue equals marginal cost. That rule still applies, and it will in every market structure. And the shutdown rule still applies for when a firm determines whether it's going to continue to produce with economic losses or shut down. So here's the main difference. Monopolies face downward sloping demand curves, and all imperfectly competitive firms do face downward sloping demand curves. The only type of market structure that faces where an individual firm faces a non-downward sloping demand curve is perfect competition, where the firm's demand curve was perfectly elastic and horizontal. But in all other forms of imperfect competition, such as monopolies, they all face downward sloping demand curves. Now what does that mean? That means to sell more of the good, the firm has to lower its price. A perfectly competitive firm didn't have to do that because a perfectly competitive firm could sell all of the good that it wanted to at the market price. So it didn't have to lower its price to sell more. But for a monopoly and all other forms of perfect competition, because they face a downward sloping demand curve, to sell an additional unit, they have to lower the price for that good and for all previous units sold. So because of that, the additional revenue they get when they sell one more unit does not equal the price. Under perfect competition, price and marginal revenue were equal to each other. But with monopoly and other forms of imperfect competition, marginal revenue and the price are not equal. So let's look at why this might actually be the case. In perfect competition, market demand for a product was downward sloping. But because of the special characteristics of that market structure, the demand for any one firm's product was horizontal. Those firms were price takers. For both the perfectly competitive firm and the monopoly firm, profit is always maximized at the output level where marginal revenue equals marginal cost. However, a monopolist faces a different demand curve. Because the monopolist is the only producer in the market, the demand for the good is the demand for the monopolist's good. And because demand is downward sloping, the demand for the monopolist's product is downward sloping. As we will see, this downward sloping demand curve creates a different marginal revenue curve, one that lies below the demand curve and thus creates what we call a gap or a wedge between price and marginal revenue. And they will not be equal to each other as they were under perfect competition. So let's look at the example of Panhandle College, a small college in rural Texas with a bookstore. And this bookstore is the only place where clothing for the PC Dust Devils can be bought. In the market for Dust Devil clothing, this bookstore is a monopolist. If you look at the first two columns of this table, you see the demand schedule for Dust Devil clothing. The third column of the table shows that the total revenue, which is price times quantity, peaks with the 5th unit sold, and then it falls. The final column of the table shows the marginal revenue of each unit sold. And you can see that it is falling and not equal to the price. So here's this first key difference. We said an individual firm under perfect competition, shown in panel A, is perfectly elastic and horizontal at the market price. So price equals marginal revenue, which equals the demand curve. But for a monopolist, because they face the industry demand curve all alone by themselves. Demand is downward sloping and is not equal to the price, and therefore is not equal to marginal revenue. So let's go back to the previous slide. Now recall that marginal revenue equals a change in total revenue divided by a change in quantity. It is clear that marginal revenue falls as more units are sold, and eventually you see that marginal revenue becomes negative because total revenue is falling if more than 5 units are sold. An important thing to notice is that after the first unit, the marginal revenue of the next unit is always less than the price of selling it. Under perfect competition, price was equal to marginal revenue. But here, price is always greater than marginal revenue. So what's going on? Well, let's take a look at the 4th unit. In order to sell the 4th unit, we have to charge a price of $12 to sell it. But we only receive marginal revenue of $6 when it is sold. Why? Well, there are 2 competing things happening here. One is the quantity effect. One more unit is sold, which increases total revenue by the price at which that unit is sold. In this case, $12. But there's also a price effect. In order to sell that last unit, the bookstore must cut the market price on all units sold. The first 3 units were sold at a price of $14 each. Now those 3 are sold at $12 each. This decreases total revenue by $6. So the net impact of selling the 4th unit is the additional $12 we get from selling it minus the $6 we lose from lowering the unit price on the previous 3. So our marginal revenue is 6. So the quantity effect and the price effect are illustrated by the 2 shaded areas in this graph. Because the quantity effect is greater than the price effect, marginal revenue is still greater than 0. We can also show a graph of the total revenue curve that shows that for units 0 through 5, total revenue is rising because the quantity effect is larger than the price effect. However, for units 6 through 10, total revenue is falling because the price effect is larger than the quantity effect. If we compare these 2 graphs quickly, it illustrates the relationship between marginal revenue and total revenue. Marginal revenue is the slope of the total revenue curve. From units 0 through 5, you see marginal revenue is positive and total revenue is rising, upward sloping. But beyond the 5th unit, marginal revenue, you can see, is negative and total revenue is falling, or downward sloping. So why is marginal revenue less than demand? Let's take a look at this in a little more depth. When we sell the first unit, we sell it for $10, and so it increases our revenue by $10, and so marginal revenue for the first unit is equal to the price. But when we sell the second unit, we have to lower the price of the first unit too. We can't charge one customer $10 and the second customer $9. We have to charge the first customer $9 now. So before we were getting $10 from the first customer, but now we are only getting $9 from them. So that reduces our revenue by $1. But by selling an additional unit, that increases our revenue by $9. So we add $9 to our revenue, but we lose $1 from the first unit sold, so 9 minus 1 is 8. So marginal revenue is equal to 8, not 9. So it's not equal to the price. When we sell the third unit, now we get an additional $8 by selling the third unit, but we have to lower the price of the first 2 from 9 to 8. So we lose $2 from that. 8 minus 2 is 6. So the price of the third unit sold is 8, but the marginal revenue is 6. Same thing when we sell the fourth unit. We get an additional $7 by selling it, but we lose $3 by lowering the price of the first 3 from 8 to 7. So that gives us marginal revenue of 4. We sell the next unit, we get an additional $6 from selling it, but we lose $4 by lowering the price of the first 4 from 7 to 6. That gives us a marginal revenue of 2, even though the price is 6. When we sell the fifth unit, notice we get an additional $5, but we also lose $5 of revenue by lowering the price of the first 5 from 6 to 5. So marginal revenue is now equal to 0. And if we sell the next unit, we get an additional $4 from selling it, but we lose $6 by lowering the price of the first 6 from $5 to 4. 4 minus 6 is -2, and now marginal revenue is actually negative. -2, and it's not equal to the price of 4. So you can see that except for the first unit, the marginal revenue will always be less than the price, not equal to the price as it was under perfect competition. So marginal revenue will always be less than demand for a monopolist. So how do we calculate marginal revenue? Here you see a chart showing the demand schedule and the marginal revenue for De Beers diamond monopoly. And you can see that to increase the quantity of diamonds sold, the price for those diamonds comes down. And the last column shows the marginal revenue, which is simply the change in total revenue when we sell one more diamond. And you can see that if you compare marginal revenue to the price, marginal revenue is always going to be less than the price because we have to lower the price when we sell an additional diamond for all the previous diamonds that we sold, because the monopoly faces a downward sloping demand curve. So to sell more, a firm must lower its price. So what happens to marginal revenue? Does the marginal revenue equal the price? Well, we've already said no, it does not. Now here we see the total revenue for each price and the quantity demanded. But marginal revenue, notice, does not equal the price. So now we're going to plot the demand, marginal revenue, and total revenue curves. Now, what happens to total revenue when the marginal revenue hits 0? Well, notice that when the marginal revenue is still positive and above 0, it's falling. Marginal revenue is falling. But when it's above 0, it's positive, and so total revenue is rising. So it's adding to the total revenue of the firm. But when marginal revenue becomes negative and goes below 0, notice that total revenue has hit its peak when marginal revenue is equal to 0, and then when marginal revenue is negative, total revenue is falling. So total revenue is maximized when marginal revenue is equal to 0 for the monopoly. So here we see a monopolist demand, total revenue, and marginal revenue curves. Notice in panel A, you see the monopolist demand and marginal revenue curves for diamonds. And notice the marginal revenue curve is always drawn below the demand curve for the monopolist. It's not going to be equal to the demand curve like it was for perfect competition. It will always lie below the demand curve. To see why, look at point A on the demand curve, where 9 diamonds are sold at $550 each. It generates a total revenue of $4,950. To sell a 10th diamond, the price on all 10 diamonds must be cut to $500 from $550, as shown by point B. As a result, total revenue increases by the green area, the quantity effect, so it adds $500 to total revenue by selling the next diamond, but it decreases by the orange area, which is the price effect, decreasing total revenue by $450 by lowering the price of the first 9 diamonds. So the marginal revenue from the 10th diamond is only $50, the difference between the green and the orange areas, which is much lower than its price of $500. Panel B shows the monopolist's total revenue curve for diamonds. As output goes from 0 to 10 diamonds, total revenue increases. It reaches its maximum at 10 diamonds, the level at which marginal revenue is equal to 0, and then it declines after that. The quantity effect dominates the price effect when total revenue is rising, but the price effect dominates the quantity effect when total revenue is falling. Now, keep in mind that past AP exams have often asked questions about why a monopolist's marginal revenue is below its price. So you need to be prepared to explain that the reason for this is because the firm has to lower its price on all previous units sold in order to sell more units. So at low levels of output, the quantity effect is stronger than the price effect. As the monopolist sells more, it has to lower the price on only very few units sold, so the price effect is very small. But at higher levels of output, the price effect becomes stronger than the quantity effect, because as the monopolist sells more, it now has to lower the price on many units of output, making the price effect very large. So, due to the price effect of an increase in output, the marginal revenue curve of a firm with market power will always lie below its demand curve. Now, a profit-maximizing monopolist will choose the output level at which marginal cost is equal to marginal revenue. It will not choose the profit-maximizing quantity of output that is equal to the price. It will still choose its profit-maximizing quantity of output where marginal revenue equals marginal cost, not the price. As a result, the monopolist produces less as it sells its output at a higher price than a perfectly competitive industry would. And it also earns a profit in both the short run and the long run. So now we look at the elastic versus the inelastic range of the demand curve. In the elastic range of the demand curve, if we look at the total revenue test, notice that if the price falls and total revenue increases, then demand has to be elastic. And you see that is true, because if price falls, total revenue is rising in the elastic portion of the demand curve when you look at the bottom curve. But once we get to the inelastic range of the demand curve, when price falls, total revenue is falling, you see that in the graph here, and demand is inelastic. So a monopoly is only going to produce in the elastic range of its demand curve, because if it produces in the inelastic range of its demand curve, total revenue would be falling, and marginal revenue would be negative. Here's a video you can watch from Mr. Clifford on the elastic and inelastic range of demand for monopolies. And here's a story that you can look at that explains when a monopolist increases output by 1 unit, why it has to reduce the market price in order to sell that unit. Keep in mind, if the price elasticity of demand is less than 1, that will actually reduce revenue. So marginal revenue would be negative then. And the monopolist can increase revenue by producing more only if the price elasticity of demand would be greater than 1. That means the elastic range of its demand curve. The higher the elasticity, the closer the additional revenue is to the initial market price. And a monopolist that faces highly elastic demand will behave almost like a firm in a perfectly competitive industry. So now let's talk about how a monopoly might maximize profit. Now, what output should this monopoly produce? Well, remember, once we add the marginal cost curve and the average total cost curve to the graph, and remember they're drawn the same way that they were under perfect competition. The marginal cost curve is still drawn like a Nike swoosh, and it intersects the average total cost curve at the minimum of average total cost, which is U-shaped. But the firm still maximizes its profit where marginal revenue equals marginal cost. But notice that is where the yellow dot is. But you would think, okay, under perfect competition, then it would charge a price of $5. But because the demand curve lies above the marginal revenue curve at that point, the firm can charge a higher price to sell that quantity of output. So it will go up to the demand curve and charge a price of $7. Now, to figure out its area of profit, you would then go down to the average total cost curve and over and shade that area so that the price it would charge would be $7 minus its average cost per unit of 6, which would be $1 of profit per unit. You go down to the x-axis and you see the quantity of output is 6, so 6 times $1 is 6, so the area shaded in green is equal to $6. So the monopolist will charge a price of $7, produce a quantity of 6, and make a profit of $6. So a monopolist is going to produce where marginal revenue equals marginal cost, just like a perfectly competitive firm did. But it will not charge a price that is equal to where marginal revenue equals marginal cost. It will charge a higher price. It will charge the price consumers are willing to pay, and that is identified by going up to the demand curve at that point to find the price that consumers are willing to pay, and that is the price a monopoly will charge. So the rule to maximize profit is the same no matter the market structure. You have to find the output where marginal revenue equals marginal cost. And that's going to appear several times throughout the AP exam, so you have to drill that rule into your head. But suppose, for now, that marginal cost is constant and equal to $10 at the bookstore that we were talking about before. This creates a horizontal marginal cost curve that is shown here. And if marginal cost is constant, then average total cost will be constant as well. And those curves will be one and the same, and perfectly flat and horizontal. Now, this just simplifies the graphical analysis for now. Many times, the marginal cost curve is that Nike swoosh, and the average total cost curve is U-shaped. So we're just simplifying for now. But if this is true, then the bookstore will find the output where marginal revenue equals marginal cost, and that is at a price of $10 to maximize profit. And this will occur at an output of 3 units. But what price do they charge? Well, here's where the demand curve is extremely useful. The demand curve tells the monopolist what price needs to be charged to sell 3 units. In this case, if you go up to the demand curve, where marginal revenue equals marginal cost, you can see that consumers are willing to pay not $10, but $14 for 3 units. So the monopolist will not charge $10 where its marginal revenue equals its marginal cost. The monopolist instead will charge $14. Now, once that quantity is found where marginal revenue equals marginal cost, you have to go up vertically to the demand curve to locate the market price in a monopoly graph. Now, what about profit? Well, remember the profit rectangle? It can be found in the monopoly graph too. Okay? You will look at the price that the monopolist charges, then you will go down to the average total cost curve, whether it's flat here or whether it's a U-shaped average total cost curve, and you'll subtract the average total cost from the price and multiply it times the quantity sold. And that rectangle will be your area of profit. So if you have to shade it, that's what you shade. And if you have to calculate it, that's how you calculate it. So like a perfect competitor, a monopolist will always choose the quantity of output at which marginal revenue equals marginal cost. But unlike a perfect competitor, that will not be equal to the price that it charges. The monopolist's price will be found by going up from where marginal revenue equals marginal cost vertically to the demand curve and then straight over to the price axis to find the price that the monopolist charges. Now, what if average total cost is higher than the price it charges? In this graph, marginal revenue equals marginal cost at a quantity of 10 and a price of $7. But it doesn't charge $7. It goes up to the demand curve and charges a price of $9. But notice in this example, it charges a price of $9, but the average total cost curve at that price lies above the demand curve, not below it. So that reflects the fact that it's making an economic loss. So now we subtract average total cost from the price, 10 minus 9, and that's $1 of loss for each unit sold, multiplied by the quantity sold of $10. So this firm, Monopoly, is charging a price of $9, but producing an economic loss of $10. Now, see if you can identify and calculate these quantities here. Total revenue, total cost, profit and loss, and profit and loss per unit. Here's another one for you to look at and see if you can calculate these numbers. Once again, we see here the monopolist profit maximizing output and price. Here, the firm will maximize its profit by charging a price where marginal revenue equals marginal cost at point A. That, you can see if we go down, is a quantity of 8 units, but the price it will charge will not be $200 at that point. It will have to go up to its demand curve at point B and then over horizontally to that price to see it will charge a price of $600. And because average total cost lies below the price, you subtract the price, 600, from the average total cost of 200, so it's making $400 per unit multiplied by the 8 units sold, and so the monopoly profit will be shaded and shown there, and it will be a quantity of profit of $3,200. Notice how that differs from perfect competition. A perfectly competitive firm would charge a price where marginal revenue is equal to marginal cost, but that would also be equal to its demand curve. And so that would be point C. So in a perfectly competitive industry, the price charged for this good would be lower than the monopoly price charged. The price for this good would be $200 instead of $600. So here we can see monopolies charge higher prices than under perfect competition. So they don't charge a price that is equal to marginal revenue. And so it's not allocatively efficient. And they charge a price that is higher than average total cost. Perfect competition would charge a price equal to average total cost, so a monopoly is not productively efficient. It's not allocatively efficient, and it's not productively efficient. So here we see a comparison that monopoly produces a smaller quantity than society desires, and it charges a higher price than society would desire, compared with perfect competition. So monopoly is overall less efficient. Here's another graph where you see the monopolist's profit. This is what is thought of as the classic monopoly graph. Remember that if we look at this previous graph, output under perfect competition was where price was equal to marginal revenue and equal to marginal cost, and this occurs where the marginal cost curve intersects demand at a quantity of 16 units, and the corresponding price would be $200. So what can we clearly tell? That the quantity sold under monopoly is less than the quantity sold under perfect competition, and the price under monopoly is greater than the price charged under perfect competition. In addition, the monopolist can earn positive economic profits in the long run because there are barriers to entry of new firms which would drive profits down. We see this above where price is greater than average total cost and there is a profit rectangle. However, in perfect competition, economic profit is driven to zero because of entry of other firms to compete. We see this because price is equal to average total cost under perfect competition. There is no profit rectangle. So this is what we think of as the classic monopoly graph, and we'll come to this in a second. Here is another video from Mr. Clifford on monopoly demand and marginal revenue. So you can watch that at ACDC Econ. Here's another video on monopoly graph review. Here's an activity we'll do in class on monopoly graphs. Here is a practice question from the 2012 multiple choice section of the AP exam that you may wish to try for practice. Here is a practice question you can do with Mr. Clifford It's micro unit 4, question number 1, monopoly demand and marginal revenue. Here's an activity we'll do in class on monopoly demand and marginal revenue. Here's an activity on monopoly profit. Here's a question, number 9, from the 2012 multiple choice section of the exam that you may wish to see if you can answer it. And so are monopolies efficient? Well, I think you know the answer to that. Monopolies are inefficient. Why? They charge a higher price than would be charged under perfect competition. They don't produce enough, the quantity that society desires, so they're not allocatively efficient. And they produce their quantity at higher costs than under perfect competition. So they're not productively efficient, they're not allocatively efficient, and they charge a higher price. So monopolies are the most inefficient form of market structure. Here you can see a comparison of monopoly with perfect competition. I've already talked a lot about this, so if you want to go over this again, you can pause the video and review it. Here's a comparison in terms of consumer and producer surplus of monopolies with perfect competition. You can see in perfect competition, consumer surplus and producer surplus are maximized. Every buyer can find a seller at the market price, and every seller can find a buyer at the market price. And so consumer and producer surplus and total surplus are maximized under perfect competition. But with a monopoly, where marginal revenue equals marginal cost, a monopolist will produce less and charge a higher price. And so, where is consumer surplus and producer surplus for a monopoly? Well, notice that the consumer surplus triangle is smaller than it would be under perfect competition. Producer surplus is a different area, so now monopolies are underproducing and overcharging. They decrease consumer surplus, but they increase the producer surplus of the monopolist. And notice that under perfect competition, there was no deadweight loss, but here under monopoly, because total surplus falls, there is now deadweight loss. So are monopolies productively efficient? Well, ask yourself, does price equal the minimum of average total cost? No. They're not producing at the lowest cost, at the minimum of ATC, as a perfectly competitive firm would. So they're not productively efficient. Are monopolies allocatively efficient? Well, you have to ask, does price equal marginal cost? No. It did under perfect competition, but under monopoly, price is greater than marginal cost. So the monopoly is underproducing. Monopolies are not efficient, productively nor allocatively. Now, the one exception to this would be a natural monopoly. One firm can produce the socially optimal quantity at the lowest cost when there are economies of scale. And when that occurs, it is better for society to have only one firm because average total cost is falling at the socially optimal quantity. Here's a video on monopoly deadweight loss review. Here's an activity we'll do in class on drawing a monopoly graph. Here's a cartoon that you can look at that shows the general picture under monopoly. And then this is what is typically thought of as the classic monopoly graph. The only difference is that it has the typical upward sloping marginal cost curve and the typical U-shaped average total cost curve. The market quantity is found where marginal revenue equals marginal cost, the price is found vertically up to the demand curve, and the profit rectangle is formed by locating the difference between price and average total cost. This is one of the key graphs in microeconomics, and you have to be able to generate it and to interpret it for the AP microeconomics exam. Many times, question number 1 on the free response section asks you to draw this graph with all of the curves, label all of the curves, show economic profit and loss for the monopoly, and label all the axes. Or they may give you this graph and ask you to interpret information from it. So you must know it. So be prepared to draw and analyze the monopoly graph for the AP exam. Remember, the monopolist's profit per unit is the difference between the price the firm charges and its average total cost. Here's another practice question from the 2012 multiple choice section, number 44. Question number 21 from the 2012 AP exam. Question 53 from the 2008 audit exam. Question 51 from the 2008 audit exam. Question 39 from the 2008 audit exam. Here's another two questions. Free response question number 1 from the 2011 AP Microeconomics exam. Here's the continuation of question number 1 from the 2011 AP Microeconomics exam. Here is the rubric for that question and how you earn points. Here is question number 1 from the 2012 AP Microeconomics exam. Here is the rubric for that question and how you earn the points. Here is question number 1 from the 2007 AP Microeconomics exam. Here is the rubric for that question. So I think what you can see from all of those practice questions, if you took time to try to answer them, is that this is a concept that is heavily tested on the AP Microeconomics exam. Oftentimes in the long free response question, question number 1, where you have to draw this graph and interpret information from it, and also on the multiple choice section. So here is a summary of what we've learned in this module. And this concludes our look at Module 61, Introduction to Monopoly.